Hello, everybody. Hello, Internet. Welcome to number 5, the 5th meeting of the Move the Bytes working group, where we don't actually move bytes. We talk about moving bytes, and eventually we will move bytes. So quick agenda up today. We're on meeting 5. It's January 18th. Yay. Really nice, clean agenda today. Just a couple of bits of housekeeping. And then Hannah Howard is going to give us a talk about a data transfer protocol, Hannah, I believe. Yes, thumbs up. I'm very excited to hear that. And then we'll just move it open discussion, which 20 minutes to the top of the hour, however long it goes, and we'll cap it off there. Housekeeping is really light. We have our new purpose. We're here to present research, compare measurements, and recommend improvements. I have some notable reading, weird position of plugging our own content, but I think this is relevant to this group. This paper came out, it was recommended by Brooke on range-based set reconciliation. I thought rather than try to take a slot in this meeting and talk about it, I made a YouTube video about it. So you can just watch that if you don't want to digest the paper yourself. The paper's kind of interesting. It's basically another proposed data transfer protocol that I think this group should consider. Didn't get any other recommended reading, but if you have some recommended reading for next week, if you want to post something, or for next meeting, it'd be great to have it for our agenda. In terms of where we're at in time, we are on our 5th meeting, which on our old timeline was sort of going to be this design phase, and then we were going to move and switch gears into a more focused implementation phase. I'm going to shift that to a discussion in the Move the Bytes working group chat about this select metrics conversation, where we talked a little bit about trying to make our protocols at least comparable. I know of a number of groups that are working on protocols, and so I'm going to try and kick off an async discussion around what metrics each of those groups either will want to collect or will collect, and ideally we can normalize on the names of those metrics and have some of those figures presentable and discussable in the following meetings. And ideally this whole group can start to shift gears just a little bit towards, hey, these are implementations that are starting to emerge. These are their characteristics. We're hearing more and more threats of demos in some of our talks. Great. I think it's a great sort of shift to encourage and facilitate of us turning towards actual code and seeing, hey, how does that work? How does that compare? How does this stack up in given scenarios? The other thing I want to discuss with others is choosing test data sets or pieces of data that we can all agree upon. I think internally at number 0, we've been playing a lot with, as an example, the Kiwix Wikipedia backups as a great test of just both a lot of content and subselections within that content for data transfer protocol. I think there are others, and it would be great as this group to sort of identify some of those data test fixtures. So I'd like to kick off discussions about those two things, picking and normalizing on metrics and using specific data sets to test against different data transfer protocols, just to give a sort of basic input-output comparability to them. Beyond that, it's kind of all we had. So Hannah, I know we were talking a little bit how you might have a little bit of vamping time to polish up your talk, but instead I will give a lovely warm introduction for Hannah to give an extra couple of seconds. Hannah has been working on data transfer protocols for some time and has led numerous tracks at our conferences and meetups around data transfer, mainly because she worked on and implemented GraphSync, which is one of the biggie protocols in Filecoin and kind of exists in IPFS, is also the fastest performing protocol behind TCP that we have based on our measurements. So I'm very excited to hear what Hannah has to say. And with that, I'll turn over to you. Hannah, hopefully that gave you an extra 30 seconds to collect your thoughts.
Yeah, no, it's cool. Mostly I collected my screen windows, but I'm going to go ahead and get started. I am actually going to share my whole screen, however dangerous that might turn out to be. Yay, okay, cool. Can you all see that? Groovy? Okay. Here to talk about a protocol called Stargate, but also it's a protocol I've been working on and even have a demo of today, but mostly I started writing it to try to think through some interesting issues with regard to data transfer. And I will caveat this ahead of time that I'm not going to be introducing any exciting new algorithm for the most part, because I am not an algorithm-y, researchy type of person. I'm more of a let's think through this problem and try to break it down in different ways and try to realize some cool stuff. So anyway, yeah, this is the title of this presentation is bringing the 90s back to Web3. And part of that is because one of the things that I'm building on is trying to look at what has already worked in the Web 2 and why does it work. So anyway, let's get started. So I have one rule that when I give presentations, and I broke it, which is never ship code for a presentation. It is the worst idea possible because it is impossible to put the code down till it's done, and then the presentation may or may not be there. So yeah, that's fun. Whatever. Let's go ahead and do this. All right. So somebody suggested to this group that rather than build another libp2p, we should build something that speaks over HTTP. And I was like, I will answer the call. I have worked on some data transfer protocols, but I think I could do better than last time, simpler than last time. So I thought I would try again. Oh, can you all even see that? God, oh, it's supposed to say okay, but I don't know what happened to it. Oh my God. Yeah. All right. Well, cool. What else? And I started off and I was like, all right, let me design a protocol from scratch for HTTP and I will, come up with the way to do it. And I started digging into it and I realized that someone had already written one. It's called the Gateway, and it is the most widely used data transfer protocol in IPFS. And I thought to myself, that's interesting. Why aren't we using that for so many things? And there's a couple of things that I could see that we're missing. One is verifiable pathing. If you dig into the gateway code, you will see that it does support car files. But if you give it a SID plus a path, you will get back a car file that lacks the SIDs in between the root and your end thing at the end of the path. So it won't be verifiable. So that's a little bit of a bummer. It doesn't have much information. Sorry, not much information. It doesn't have the tools to transmit data for someone who might want to make a multi-peer request. And similarly, it doesn't have it doesn't really have queries that you would want to make for a multi-peer request in many cases. You could use it like if you're getting a directory, that might work well for multi-peer, but like if you were getting a video file, like it's not super obvious how to get a verifiable like range request into a big giant Unix FS file, and it's not possible with the gateway. You can get a raw file with a range request, but that won't be verifiable. So anyway, I was like, okay, well, that's cool. What if I dig into this? So yeah, I'm going to introduce this protocol that I wrote called Stargate. And all Stargate is basically a new format, response format for gateway queries, plus a few other things. And at this point in the presentation, I'm actually going to switch over to the initial specky thing that I wrote for Stargate. Yeah, so basically, here's the deal. Here's what Stargate is. It defines a new MIME type response format for a gateway. It's just a car format with a little extra on it. So the response format is still a car. It just has some other things in it. And then it defines some additional query parameters for doing different kinds of queries that you might not be able to do with the gateway currently. Yeah, so let's look at the format. So basically, you give it a normal gateway query. This is taken directly from the gateway pathing spec. And you will get back a car file. It will have your root SID as the root SID in the car. However, the first SID after the car header is going to be a Stargate message. And here's a Stargate message. It's a pretty simple type of message. It simply has one of two possibilities. It's either a path or a DAG. What you'll have is basically the first message will, if you have path segments, will be a path message. And then in a path message, sorry about this, I'm also like super tired from doing this. You're going to have a list of segments that the path message covers, and then you're going to have a list of metadata about blocks. And the blocks are basically just SIDs plus a status. The important ones are like, I didn't send it with this request, and I did send it, that's present. I'm actually missing it, which is useful for, if you want to do partial. And this is a duplicate, which means that you're not going to see this or anything below it in the response. And so basically what you're going to read your Stargate path message, and then immediately following that message, there will be all of the blocks that were marked, that were listed as block present, right, in that message. Now, so you're going to read the message, and then you're going to go ahead and read all the blocks, and then at the end, you're going to look for another Stargate message, right? Now, the next message could be another path. Yep. What's up? Oh, no. Unmute issue. The next message could be another path message, or it could be the beginning of a DAG. Each path message is basically covers some or all of the portion of the path, and to switch to DAG messages when you've gotten to the end of your path segments by combining all the ones you've traversed so far. So then you get a DAG message, and a DAG message is probably even simpler than the path message. It is simply an ordering, which right now has two values, breadth first and depth first, and a list of blocks, again, with the metadata. And that's the entirety of the protocol. For the DAG part, you can have one or more DAG messages followed by the block sequence. And it's the same algorithm. You just read as many blocks as you need to get all the present ones in the Stargate message, and then you look for another Stargate message. And so actually, whether or not you can actually send, if you have a path query with and then a DAG at the end, you can send just one path message followed by all the blocks in the path, and then one DAG message followed by all the blocks in the DAG. Or you can send multiple, and actually there is not a decision made in the protocol itself about how that will be broken up. However, it will be specified in what I'm calling the application protocol that you're using, and I'll get into what that is in a minute. So yeah, that's pretty much all it is in terms of the protocol. And essentially, this allows you to stream back a car file. I'm using car files because it's something that everyone knows. There's some hiccups around here that, pluses and minuses. Among other things, car files have SIDs in them. And so I am hashing the Stargate messages. They're very small, so I don't expect them to take a while, but it's probably not the most efficient thing. I've gone back and forth about whether I should be using cars, but everybody loves a car, and there's lots of tooling out there, so I thought I would go ahead with it. And that's the protocol. So that's all that's all there is to it. I want to talk about why we should use HTTP. Yes, Droba, there will be questions at the end. I promise, I double promise. Why would we use HTTP? So there's a couple of things that I've dug in there's sort of the stuff that people know. Everybody, HTTP is incredibly widely deployed. It's very easy. It's good with web browsers, all that stuff. But if you go back to HTTP, there's a couple. If you go back to the design of HTTP, my first programming supervisor was a devotee of a guy named Roy Fielding, who came up with HTTP 1.1 and this principle called REST, which was this set of tools for building an incredibly widely distributed system. And so HTTP, that's part of the reason HTTP works, is because of its design is built to support lots of caching and getting things from anyone. And the URL provides a really good, is essentially your cache key. And this is actually an interesting property that we really haven't thought about taking advantage of, but a URL is actually a great constraint for a selector, right? What? If you can't fit it in a URL, then maybe you have too complicated a language. And I don't mean a selector, but it's a great constraint for any kind of a query, right? And if you look at URLs over time, people have built complex, highly dynamic applications. UnixFS, the application we're sort of building with IPFS, is almost like the Web 1.0, right? And they did that fine with URLs. And then, but you think about like Web 2.0 is all these dynamic applications that were built with just URLs as their sort of like go-to, and it makes for this really interesting like mechanism for caching, which makes the system easy to distribute. And we should have a really good advantage here because we should have true highly cacheable content because of the nature of content addressing. And we haven't really always had that yet, but I think it's an interesting constraint, and the URL is a really interesting way to limit what you can do. And it's sort of, and you know, we often go back and forth about, well, like what kinds of queries should we support? Should we support pathing? Should we support something more complex like selectors? And I think that the rule that I would put forward from having looked at the gateway spec, because actually the gateway people have been like, the folks who built the gateway have been building this out for a while, is if it can't fit in a URL, maybe you haven't done it right. Anyway, so that's just a sidebar. Yeah, so that's that. Okay, good properties of HTTP. Let's see what else. I have another question. So this is something that came up for me. What does the /IPFS in a gateway request mean? So if you actually dig into the IPLD docs on ADLs, there's a section where they're like, well, an ADL is like the /IPFS in the gateway. That's actually like kind of an ADL. It's a UnixFS ADL for pathing into UnixFS. And I'm like, that's cool. That's interesting. But then I was like, okay, let's talk about what an ADL is. And I had this fascinating conversation with a dean a couple of days ago, where we came to a disagreement about like where the bounds of an ADL was, or not a disagreement, we have different ideas. So show of hands, who thinks a HAMP is an ADL? ADL is an advanced data layout. Would you call a HAMP an ADL? All right, somebody raised their hand. Yay. All right. Yeah, who knows? Okay. ADL, by the way, stands for Advanced Data Layout, which provides a different lens from which to view data. Okay. I think the HAMP ADL is like, HAMP is like the canonical ADL, actually, right? It's like very clear. All you want is a map, and you want to represent it as a, you know, you want to be able to interact with it like a regular old map, but underneath it's this multi-block structure, you know, that's, you know, that represents a complex, immutable way of representing a very large, I don't know, map in memory. I don't know. There's a whole talk on HAMPs from IPFS camp. I encourage you to go see it. All right, but here's another question. Is UnixFS an ADL? Right? So this is an interesting one. Is UnixFS, the whole thing, an ADL? Not a UnixFS directory, not a UnixFS HAMP directory, not a UnixFS file, but like the whole thing put together where you can path into it and get the files back. It's okay, open question. You don't have to raise your hand or not. But I found this, so this starts to get pretty interesting because it's not just a data structure here over multiple blocks. It's like a whole file system, right? It's like, it is a data structure, which is like the directory, which actually also has a HAMP in it for one form of the directories. And then you have the, and then you've got files at the end of those directories, and it all links up together, right? All right, let's try this one more time. Is the Filecoin chain and the entire Filecoin state that hangs off of every tip set in the Filecoin chain an ADL? There are HAMPs and all kinds of things inside of Filecoin, right? Like there's all kinds of those things. There's very complex data structures, but it all links together, okay? And so there's like this thing about levels of ADLs. It's not well defined. This part of IPLD is not well defined, okay? What do you call this like thing that when you put everything together, right? I started calling it an application, right? Because it's kind of like what you're doing with IPFS. I mean, IPFS, I guess, it's a protocol. It's not an application. And then I was like, well, let me rewind and think about what it was like when I used to build things for Web 2. And I built applications for Web 2. And when you started to build an application for Web 2, you would start by building something called a domain model, right? A domain model is basically thinking through the structure of the type of thing you're trying to build and figuring out all the entities within it, and then figuring out how they relate to each other, right? And you actually, in Web 2, you could be, if you build a Web 2 app, you have this complex domain model, and then you have these endpoints that can do all kinds of crazy searches into your domain based just off of pathing, right? And this isn't just static files. This is like usually talking to a database. So anyway, so this is something that I've been really interested in. And I would put forward a claim, which is ultimately the thing that is really interesting and really enables powerful queries is a whole domain model, right? The reason that the gateway is widely used is because it has because it understands all of UnixFS, you can just do this little path and then you get what feels like the most powerful thing in query that we do in IPFS, which is Web 1.0. Let's look into directories and files, right? We still haven't gone past that. But it's still like, this is useful, right? If you have a domain model and you have complex understanding of what's going on, you can do complex queries with not a lot of information. Anyway, selectors could be their own domain model. Maybe just IPLD itself is a domain model. I don't know. It's an interesting question, but I think it's worth considering. And I actually have taken the liberty, probably this is the most controversial part of this proposal, which is I am considering the /IPFS part of the Stargate protocol to be the UnixFS application or UnixFS domain model. Further ones could be added at a later point, right? And you could build it. And the goal here, and theoretically, this might solve some of our one to more protocols. Well, maybe what you need to do is build the ability to put in applications and transmit them around. And plus we have WASM, and you can just, transmit around applications super easy, barely an inconvenience. It'll and you just distribute them widely and anyone can figure it out. So that'll one day all work. In any case, in the meantime, it's more food for thought. Cool. Let me see where I am in this presentation. Yeah. I want to talk about one more thing. There's this statement I've heard a few times, DAG traversal is considered harmful. And this is coming from some folks who are building the most scalable, largest IPFS implementations in existence, right? I think that's interesting, right? Why are the people who are scaling up IPFS saying DAG traversal is considered harmful, right? What's the why here? Well, my proposal is that DAG traversal is not scalable in its current form, right? Let's talk about what DAG traversal means. I start with a SID, I load the block from disk, I deserialize it, I look into it, find some relevant related links and SIDs. Then I go ahead and go through each one of them, load their block, deserialize it, probably doing this all one at a time, right? In the best case scenario, I have some parallelism. And I repeat the process ad nauseum. And something that's been interesting to me, you just keep recursing until you have no more SIDs to traverse. Could we do better, right? So this is something that's been fascinating to me for a while. I was like, why can't we answer the question, what SIDs are in my DAG without having to read through every block? And I think, and sort of to me, the answer to this is you need some kind of metadata information about the DAGs. And I started off thinking about how can we build a general case metadata data store for IPLD that can answer IPLD queries quickly. And I came to the conclusion that is too hard. Maybe somebody will do it, and maybe somebody who's smarter than me will do it. But the problem is trying to answer general case queries about IPLD without looking at the blocks. You get into a lot of hard problems, are two nodes in an arbitrary directed acyclic DAG connected? That's not super easy to answer in some 01 type time. So I was like, what if? But if you limit that metadata, or you make it specific to a domain like UnixFS, you can actually answer almost all of the queries. Cool. So I think this is actually the point where I want to think I'm going to switch over to a demo. Actually, yeah, let's switch over to demo. Again, this part is a little out of order. I just want to show you the thing works, and then I will show you some things about how it does it. Okay. Cool. So I'm going to go to terminal. This will definitely be the part where I hope for the best. All right. So this is my command line. I am going to start off. I have a Stargate little program that you can run, and I'm going to start off by importing the entire code repository for Stargate into its little thing. So I'm going to go ahead and do that. Oh, it works even better when you remember the dot ahead of time. This is why no live demo. All right, cool. All right, cool. All right, so I've imported the thing, and this is like the entire recursive directory has now been imported into Stargate. Part of the reason it goes fast is because it's all done with the file store abstraction, which basically allows you to write block stores that aren't really block stores, but really just references to existing files on your system. Cool, so I did that and I got a root SID. I'm actually going to do one other thing because almost all the files in this directory are basically very, very small. And so I am going to import one other thing, which is I'm going to import a little video. Let me see if I can get this right. Okay, yeah, there we go. Cool. Great. Okay, so now I have two SIDs. And now I'm going to start my Stargate server. I could have started this before, but whatever. All right, I'm starting my Stargate server. All right, you have a port. Now, I have not finished the client, so this part of the demo is going to be a little bit of a bummer. Well, it's not going to be that much of a bummer because I figured out you can show that it's working without all that. So we'll see. All right, let's do a thing. All right, so first let's just try to get the root of the root directory of my code repo here. So let's go ahead and we're going to do it with a really fancy program called, yeah, there we go. This is the curl program. I don't know if y'all have used it before, but I hear that it can get you some things. Okay, I've got so much. This is why we don't live demo, because now you have to wait for me to type, and you're going to realize that I don't know anything about how to use terminal shortcuts to move your key to resolve things quickly. I know Control A and Control E, and that's about it. Okay, so cool. I'm gonna put this SID in here. And you can see that we got a 200 response, and we did download the file. It looks like it was 177K, probably because it's got a bunch of SIDs in it. And actually that's bigger than I would have thought, but whatevs. And then to prove that this is actually working, I will do a pathing request. And I will do a go.mod. Go.mod here being the oh wait, that's the download speed. Sorry, the transfer is only 4,000. 881 bytes for the top level directory, 4,000 for the go mod. Oh, because there actually aren't that many bytes in the top level. There aren't that many files in the top level directory. Let's just check over here on our server. Yes, these are succeeding. That's good. And just to prove that this is actually doing a thing, I'm going to download something that doesn't exist in this directory. Okay. Yeah, and you can see that I got a 404 not found. And I got a 404 not found over here. And it's saying that there was no file or folder named cheese. Okay, cool. And so then I'm going to go ahead and do I'm going to do something else, which is I'm going to go ahead and try to download something that's in a nested directory. So let's see, package. What do we got here? Package/types.go. I think that's a file. Yes, there we go. Another 200, and we got that to download. Cool. Yay. All right. So now I want to show you some cool things about some cool things you can do with UnixFS files with this protocol thing that I wrote. So let's get our other SID, and I of course failed to copy paste it. And let's try this. Okay. So now I'm going to download this video file. I'm actually going to add a parameter at the end called leaves, right? This is going to give me the whole video file. Leaves is actually a parameter that says, give me the bottom of the UnixFS thing, the raw blocks at the bottom. By default, Stargate does not send that for UnixFS. Maybe I might switch those defaults because people expect the whole thing to come back. But you can see I transferred 10 megabytes. And if I go ahead and take off this, now I transferred 4K. And I think this is a really key thing, but in that 4K is all the SIDs for all of the other, all the leaves. They're just not the content. I think this is a thing that we could be, particularly for Unix FS. Like, to me, that's an obvious way to deal with file queries, right? Like you want to split it up. The simplest thing to do is to not send the raw things and then fetch them between lots of different peers. Now, I haven't written a block protocol, but there is a block protocol on the gateway, right? So that's a thing. And then I want to show you one other thing. I'm going to put my leaves back on, but then I'm also going to do another thing, which is I'm going to go ahead and say bytes equals, let's say 1. Let's go 10,000 to 3 million. I don't know. I'm just making shit up right now. Is that 6 zeros? I think so. Let's see. Oh, no. 200 okay. Failure writing. Did I spell it wrong? Probably did. I did this right beforehand, and then I broke it. Now I remember. Stargate's not broken. I forgot that and characters are escaped in. So you can see here, I transferred 3 total megabytes. That's a little less than a little more than this. And that's because it has to transfer in block amounts. But you can see that there's a unit, a query that's really useful for Unix FS is give me a byte range. Now, you can't really use a HTTP range request. I mean, you could use the range header to do this. The reason you don't want to is the range header has a very specific meaning. The only proxy supported meaning for the range header is a byte range of the actual response. And Stargate still supports that as well, but like the thing that's useful for like verifiable data is actual range of the underlying Unix FS, but giving you the whole car. So this is another thing that's kind of useful to do. And like my thought is, like, so those are the parameters I came up with for Unix FS, just off the top of my head. You could come up with lots of other ones, right? And presumably every application would have to have a spec that would describe what does it support, how does it work, how does it chunk up messages, all that stuff. Cool. I want to show you guys just a couple of things about the code. And the first thing I want to show you is my sort of like solution to how to query Unix FS quickly. And the short version is, again, I fell back on Web 2 and built an SQL database that tracks everything that you care about for Unix FS data, right? I haven't even tried to performance optimize this, but basically what you've got in here is, here, I'll show you the schema. It's like, basically you've got a concept of directory links, which are just like a link between a root SID and like another SID in the directory. This is actually an interesting, complicated thing because you want to support both HAMPs and non-HAMPs. And HAMPs have like each link to the file is like each subpath has one link, but in regular directories, but in HAMPs, each subpath has multiple SIDs. So I sort of built a thing that'll assemble this. And then for file links, basically I built a thing that essentially stores the important information that you get out of the Unix FS header about the file itself. And a lot of this stuff is in the block. It's just that it's just not saved and easily queryable. And this is how you can do these byte range queries. I have another table that's just like things that are roots in Unix FS. Like, so the concept of a root in Unix FS is interesting because a Unix FS block is not inherently a root. And there's right. So this is an interesting, and it's not always obvious either, whether it's a root or not, like both for Unix FS files and for HAMP directories, there's a bunch of intermediate nodes that just looking at them on their own, you can't tell if they're roots or not. So anyway, and then I wrote a bunch of utilities basically to traverse Unix FS and like find all this stuff. And when you look at the actual way this whole, I'll pull this up. I'm going to show you the import command and what it's doing. By the way, with the roots, you'll notice there's this metadata thing. There's an interesting question around like I'm not answering how are you storing your data, right? Like I'm not answering your choice of block store. I'm not answering if you're only using one or more. And because I work for a Protocol Labs and we built a thing called the Filecoin, our data is stored in giant pieces, which are like separate car files. And so I wanted to make sure that my thing would be useful for a Filecoin type storage, because that might make my team want to actually use it one day. So this metadata in the case of Filecoin actually would just point to like a PSID or a car file or something, that the things you would need to do that. If I look at the actual import command, what I am doing is I'm essentially, reading in the car file. Yeah, oh, right. I'm reading the directory in, writing out the whole car file of all the things that are in that directory. It's a recursive walk through the directory. And I'm actually not trying to build a database at that time, because I wanted to get to a flat car file and then reassemble it by scanning the car file. Again, this might be useful because we don't have data in this form currently. So if I can't scan a flat set of blocks and extract this UnixFS data, it's probably not that useful. So in any case, so I read the whole thing, and then I initialize this store, and then I import it. And the import process looks like essentially reading all the SIDs in the store and running this program called discover roots, which reads through blocks, and basically, if they happen to be in raw format or in protobuf format, and then like if you read in the protobuf ones and deserialize them, then you like read that they're UnixFS, then you start putting them in this list, and then you have this system for like tracking like which ones are roots by like initially assuming everything's a root and then finding out it's not when another UnixFS block points to it. And then once you've got the roots, then you add all the intelligence by scanning again through the files. It's probably not the most efficient thing, but it is something you could run on an existing block store without any big changes, which felt important to me. Anyway, so that's how that does that. And then when you actually make a request, I want to just show you the concept of basically like the concept of how you would respond to a query, right? I have this concept of a resolver. And this is actually kind of a steal from yet another Web 2 thing, which is GraphQL. If you look at how you're supposed to implement GraphQL servers, almost everything in them requires you to build a thing that says, given this query, resolve it for me. And so with the way the app resolver works, it essentially starts with the first thing you have to do is resolve the root. And when you resolve the root, you actually return the block store you're going to use. This is an IPLD link system, which is just the IPL-deified block store, and then you get back, and then you get a path resolver, and then the path resolver can do one of two things. It can try to resolve all the path segments, and when you resolve, you get back a path message. You get back the path segment, you get back the remaining path segments, and then you get another path resolver, or you can convert to a query resolver, which basically means resolve the rest of the DAG. And then I've got a thing that can just walk this, then I have code that'll walk this and build the response based off of that. And the query resolver just sends DAG messages back. So an interesting thing about this is that none of these resolvers are reading block stores. There's no read of the block store. That's why it returns this IPLD link system. So this is all, if you look at the UnixFS implementation that I've built, it's all using this database as the thing that, reads out all of this information, right? So this is the UnixFS store. It can do a dir ls, a dir path, a file all, file byte range, a root SID. It doesn't really matter. These are the things. Anyway, so that is all done without ever looking at the block store. And then you have the actual car writer, which is not optimized right now, but it's not very complicated. It has the link system. It gets the messages. It reads them out of the block store and writes them. And I figure it can be super pipeline optimized at some point. And the idea here is that, basically, this thing is a separate responsibility and it's never deserializing blocks. So that's kind of the basic idea. And again, I think the way this resolver is built, it could you could support other things. If you wanted to build a Filecoin one, you could build it. I might try to do that one day if I acquire about 1,000 hours of random free time. But you could, I think, I don't know, we'll find out. Again, it's all built around the structure of URLs and how you might want to resolve things in different applications. Now, if you actually Sorry, I'm going to rewind for 2 seconds. Oh, right. Yeah. And if we build this and we build it all the way out and it's super awesome and we can do everything with Web 2, then we can go to the next level and start building like an actual selector GraphQL type interface. Maybe we should put that at the end rather than at the beginning. So yeah, that's the basic idea. I'm trying to think if I have anything else. I apologize. I'm just sort of like scanning slides to remember I've covered everything. Yeah. So that's the deal. The code is available, yeah, no, it is available. I think it's I'll send more information after this. But let me see, where's the chat? The chats. By the way, there's like a little like, I don't know if Dig is on the call, but if he is, I may or may not have like taken some ideas from him. So I want to give credit because he was like, let's just do a path and dag underneath. Oh, by the way, another thing that's great about paths and dags is you don't have like duplicate logic is really straightforward. One of the worst problems with selectors is figuring out how to arbitrarily tell if you need to traverse something again. And you don't have to do that as much with an all selector or path selector. With path selector never has a duplicate, and an all selector, you can always assume that you don't need to traverse it again. Hold on 1 second. Let me just send the URL. I'm going to put it into here because I can't remember what it is. Okay, I have no idea how long I've talked for, and I apologize if it's been on the super long side. It is in the IPFS repo, which I can move it to my own. I didn't like know. Apparently, I still have some level of admin access, which allowed me to push this. So not admin access. I have like what I'm on like the Go core team still from like 2018. So that's why it's there. And here I'll send you the protocol spec. This is all like super rough, so apologies. Anyway, there you go.
Thank you, Hannah.
Yeah.
Much appreciated.
Oh, sorry about the lack of raising the text size.
Embiggening the text. That's okay.
Yeah,
I could read it. Cool. Do you mind nixing screen share and we can go to some questions and discussion?
Let's chat.
Who has thoughts? Who has questions? Adine.
I'll let Lionel go first. His are generally better.
Lionel asks good questions. Lionel.
No pressure, thanks. Okay, so I like it. I think that's the gist. I just wanted in the meantime I was like taking notes because we were looking at this already, but I think that Hannah just bridged the gap by introducing the concept of like application of IPFS, like and like making like UnixFS domain specific, and the prefix /IPFS defines the domain more or less provisionally. With that, and lives and bytes parameters are really useful. Something we did not consider before, but I see now how they are useful. We had the discussions about depth, but you don't always know the depth of the DAG. So the lives flags is really useful. I dropped some notes on the issue about like car export with selectors. When we quickly realize we don't want selectors. So there's like a huge, I think there's like a huge alignment in what it's like in the direction we wanted. And I feel from the Kubo perspective and other implementations that already implement, let's say block and car on gateways, it would be easy to extend, I feel. The only, there are like the only questions are around like error handling. The content type and accept headers are often ignored. So even though the dedicated content type is nice, gateways will often just return you bytes without saying, I don't know what it is, I will just give you HTML. So those are like the quick notes. I think like from the perspective of mobile web browsers, which do not want to run full peer-to-peer or P2P stack, it's also like really nice, especially the byte range one. The ordering and the duplicates are open questions. But that's the kind of like high level that I'm aligned on the direction.
I think there's more feedback than questions, right? And just Hannah, if you don't feel the need to respond, Nadine, you can go ahead.
Okay, cool. Yeah, I guess a few things. So I as Lytle said, also a fan. I think like I tried putting together like a matrix of like some of the protocols that we have already and what's going on. All of the request response protocols, you want to use like HTTP or like carrier pigeon or TCP, like who cares? And HTTP has like caching and stuff by Cloudflare and Amazon. So yeah, do it. I think there's like a few awkward things about like choosing like /IPFS to mean UnixFS based on some things that people have done in the last year and a half that they were not supposed to do according to some people or not other people, that have made it like not a UnixFS thing. For the people like Brendan who are going like this, I'll give like a brief TLDR, which is there may or may not be a bunch of NFTs that you can do /IPFS/CBOR object/ foo, which is a UnixFS file. That aside, at the moment, you know, I like the bytes and bytes and leaves. I don't know if there's other things that we need, particularly around directories and like what level of access people need to directories, but basically URLs good. Getting something that is like usable enough as a graph descriptor that people can work with it, also good, because at the moment everybody hates all of them, right? Current /IPFS not good enough. I don't have byte ranges and such. Selectors, I hate them. They're too complicated. I'm ignoring everything except for blocks. It doesn't work because I have HAMTs. So like finding that feels like one of the key pieces is like just getting that descriptor thing we can align on. I guess maybe a question is like, or a comment is like, awkward thing about car files is like, and streaming them is I don't know when they've terminated. Which basically is what Lytle was, I think part of what Lytle was getting at with error handling. So if you go to today and you do ipbest.io and get a car and then it dies in the middle, there's no way to know unless you go and validate the car, whether that closing was accidental or not, or as the result of an internal error or a Comcast error. It just kind of happens.
Yeah, so something about this is interesting is that like this is one potential downside of HTTP is you're supposed to or at least the go lot like the way HTTP works, as I understand it, is like the header comes first, followed by the rest of the response. So it means you have to kind of like decide ahead of time whether you're going to succeed or fail, or like and why, right? And I actually, so what I'm doing at the moment, and it's super probably not the right solution, but it's a solution, is I'm actually writing the car file to a file, and then just streaming the file. And then you send your connection could still go down, but that is like more of a, I think that is expected behavior. That's more how HTTP is expected to work. It also, I mean, for what it's worth, it enables range requests if using the header range, if you care about that. But the interesting thing is that, and then you can decide and give generally right. It doesn't support streaming errors. Bummer. But that's a thing that I did for the time being just to make it work with HTTP. But yeah, it's not probably optimal. Then again, hard disk reads are cheap. Maybe.
Well, it's you can beat it, right? It just involves not using car files, but doing something else, like something that's optimized for transport.
Mm-hmm.
Yeah. I mean, I was partly going towards like, that's a totally, I was like, why don't I have this problem in GraphSync? Because GraphSync is a series of messages, right? So it can just change it at any time, versus HTTP is a request and a response. And you generally expect to get one response back. Now, I guess you can't really do a server. I heard you could do a server push, but then I Googled it and apparently server push is dead. Like,
no, it's not server. Sorry, I think Jeropo has comments because he's
has better ideas
too.
than I do. I'm not actually good with HTTP. So
if I were to solve this, I would like add message. So you're already adding your messages into the car file, and you could do the same thing with different messages that like instead of having an error, let's say you find an error in the streaming, you add some special CIDs that indicate, oh, actually, I'm done now, I'm not finished. Like I cannot finish, you have an error. Or another one would be, right now, the car file is expected to terminate when the body terminates. But because HTTP wants awesome, sometimes the body terminates and you don't actually know if that's on purpose or not. It can be for multiple reasons. So we could say, let's say we add like a magic empty element. So you make like a zero block and a zero CID, and you add that to the final. And like, let's say now we can decide that, oh, this is the end of a car file. That would be a pretty small change to the car file spec, but seems like a.
It's like null terminated array, right? Just
yeah.
Identity CID, identity hash.
Or not even that, just make a value int that's 0. Because like
it needs to be not valid. It needs to be not valid so somebody doesn't have a graph that includes your block that looks like the null terminator, and then you die in the middle.
A 0 block is fine because you cannot have a 0 CID, I think. Hopefully, please.
There's actually it might be worth looking into.
Another option, Hannah. I really appreciate you calling attention to the construction of an index as a means of bypassing the expense of the store, and pointing to it as a required ingredient of a data transfer protocol. We have this in IRO and have had it from day one, where we just have an index of everything and don't touch blocks. And all of our stuff is built as with that as a prerequisite in mind. And so I'm delighted to see that like common substrate. Just to specifically touch on this bit, because you have that index, if the car file or whatever transport mechanism you use is specific enough, you could theoretically know your byte length based on your query beforehand, right? You can actually get to the point where once you hit a certain level of determinism in your selector, you go, okay, cool, compose all that up. This should equal blah based on just summing and accounting of bytes of blocks. Maybe, and then you get your fancy streaming stuff, but like you'd have to be damn sure that it's going to be good accounting. But like we have unit tests for that. But I want to go in some other direction, specifically the question about how seems like you've really wrestled with is the connection between the protocol and the application space. And you've made a pretty declarative statement and said, if we poke up into application space and say, this is how we're going to constrain the system such that we can more meaningfully talk about it. And I thought your ADL existentialism was a really great way of getting to that. And so I think the natural question that begs is really about IPLD and how would you, now when I say IPLD specifically, applications that don't obey the UnixFS sort of universe of tools. And if I understand correctly, your protocol is implying that, not implying, you said it right, we would have other extensions that would have other applications, which would require us to be able to plug other mechanisms for people to write different things that are non-UnixFS. Is that right?
Yes, though I would argue that the arbitrary IPLD is itself arguably like the arbitrary IPLD stack, aka, data model, codecs, like what's it called? Schemas and ADLs is itself an application. It's there's a proposal for a /IPLD on the gateway as a root. And I think that's worth supporting and building out, right? And we could totally build that out. And there's some fascinating things they're doing with the path segments to signal ADLs and all that. I don't know where that lands, but my and that might be useful for maybe IPLD is useful just arbitrarily for a lot of applications. My belief is that when you really start building applications, which to me is the core component of what makes the Web3 and the content address data, not Web3, the content address web take off is when you can build cool stuff with it. And in my mind, people are going to want to write simpler queries and more optimized queries, because when you know a lot about the data model, you can do a lot, right? So, yeah.
Love it. Does anyone have a last question? Nadine's got a thought.
Yeah, so this is, I guess, just the I'll say the thing that lives in the middle. So once you get, one of the difficulties with this, it's just, I guess, just IPLD stuff in general with I get to write arbitrary code for my application, whether it's a codec or an ADL, or I guess maybe a hash, but we'll ignore the hashes and pray you use a normal one. is that like sometimes people aren't going to want to do these things. And I know that you could just like WASM all the things, but I could also just define my data transfer protocol as exec WASM module, and then like we can all go home. So if we assume that that's not what's happening, then you still need a way to deal with like the blockish side of things, right? The like, it sucks. I wish that, you know, Web3.storage supported a Dean Fancy ADL, but they don't. They just support UnixFS. So I'll get my stuff from them. It'll just be slower. And when we do that, if you have like a block protocol that's like one block at it, deciding what we want to do about, we'll call it granularity of caching, right?
Yeah.
You can do one block at a time with like CID block, 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 or I can group them together and ask for more stuff.
Mhm.
And I think like that probably, it's like there's that boundary between like, oh, we have an HTTP protocol for single block.
Yep.
We have a bit swappy thing with lots of blocks. Maybe we need to also be able to do groups of blocks, or we need to analyze what the caching parameters of that look like on real data to see how
Yeah.
much we need it.
Yeah. So I actually originally intended to write a companion like multi-block request protocol. And then I realized that building an entire new protocol outside of my regular day job was probably a little bit ambitious. And so, but like I had some ideas on this front. Like the caching thing is really tough with multi-block, right? Like, because like you can't really like once you have a combination of SIDs, like how are you going to cache them? Arguably, I guess you could hash them together and then you get a hash key. It just wouldn't be a very useful one, right? Like, because unless somebody asked for the exact same set of blocks, it wouldn't be useful. So my thought was on that front, maybe punt on caching. I don't know. Like, but then it was like, oh, well, what could we do there? Because there's a lot of questions about what we transmit. And my thought was, okay, so you get this response back and you now know all the SIDs you care about, theoretically. I don't know. And so my thought was at that point, you actually would be if you really wanted to get fancy, you could like take all the SIDs you want, split them up among, you know, the 5 peers that you know have this thing. Hopefully you know that at that point. And you could build like 5 Bloom filters of like which SIDs I actually want. And the nice thing about doing it that way is that I believe the property of Bloom filters works in that direction where you'll get a little extra data rather than a little under data. So it would be a single request. Somebody with Bloom filtering knowledge will have to like check me on that. But I believe if you say, I want these SIDs expressed as a Bloom filter, what you will get back is those SIDs plus a couple others, depending on what they have. And you would still give the root SID. So like you would be like, I don't know, you could do you could also do like a bitmap or, you know, any of those ideas that people have been throwing around. But I sort of like said, well, multi-block block protocol. Well, first of all, there's a bit swap available for a lot of people. And then second of all, like, you know, like there's a HTTP block protocol. It's not particularly powerful, but you know, whatever. And then lastly, there's like, you could build one and it, you know, it's a separate problem. So yeah.
Yep. Also, I don't know, I think you were at my talk last time, but one thing I did because I tried mocking out something similar to what you did is a way to describe large blocks inside of the requests so that if somebody has like a 100 megabyte block in the middle of their graph, that you can break that up into pieces too. And that also requires signaling. But given that we are already going to need signaling for things like termination, it seems like it's an easy enough thing to include in what you're doing. Really cool.
Sure. Before we shut down, I just want to say one thing, which is that, so in terms of like what I'm prepared to do on this protocol that I've just built, I'm going to clean it up a little bit, add a few more tests, maybe do some measurements. But I'm not going to keep developing. Yeah, I know measurements. I had so many conceptual things to figure out first. I was like, I know that I would. Yeah, actually, it was all going to get done before this presentation, and yet somehow not possible. Anyway, I am going to. So yeah, I'm gonna maybe do that, but then if I can, But I actually am not going to be the one to keep developing this. So it'll really be up to this group to figure out if you want to pick up and do something with it. Maybe there's some useful stuff. Yeah, so there you go.
Fantastic. Thank you. Perfect handoff. Thanks so much, everybody, for joining. And we'll see you in 2 weeks, February 1st. Thanks, Hannah. Thank you for talking. Bye, everybody.